Hey everyone, welcome to my channel Dentistry Talks. Hi, this is Dr. Soumya. In this video, we're gonna talk about the mechanism of action of local anesthetics. Before knowing about the mechanism of action of local anesthetics, first let's talk about how does the pain occurs. Here I'm gonna talk about the action potential first. Here what happens? The sensory neurons are the neurons which take impulses from the peripheries to the CNS or brain. Basically what happens when there is a stimulus or when something happens to the body, this information has to be sent to the CNS. How this is sent? Through the sensory neurons. This information is carried as a impulses from the peripheries to the central nervous system. The impulses could be touch, heat, pain, or any proprioceptive stimulus. Let's see the nerve terminal of sensory fibers in a normal state, which means when there is no stimulus, there are a lot of potassium inside and lot of sodium outside. And its resting membrane potential is minus 80 millivolt, which is when the nerve terminal is at rest, its potential is minus 80 millivolt, and it has lot of channels. There are two types of channels: voltage gated channels and ligand gated channels. The voltage gated channels opens due to electrochemical gradient, and the ligand gated channels opens by ACH, which is acetylcholine, by neurotransmitters. When there is a stimulus, let's take it could be touch, pain, heat, or any stimulus. When there is a stimulus, the sodium gated channel opens, as a result of which the sodium starts coming inside. When there is more sodium starts coming inside, the threshold also increases. When the stimulus is high, so more and more number of sodium starts coming inside, the threshold, it reaches its peak. This is the wave of depolarization. That is, when more and more number of sodium comes inside, there is wave of depolarization. Along with the calcium gated channel also gets opened. Through this, the calcium also starts coming inside. Once the calcium also starts coming inside, the choline also starts coming inside. The acetyl which is present in the mitochondria reacts with the choline to form acetylcholine. There are a lot of calcium binding receptor. This acetylcholine, what it does, it binds to the calcium binding protein, as a result of which it gets released at the nerve terminal. Once the ACH comes out at the nerve terminal, on the other side there are nerve terminal with the ligand gated channels. In response to these ACH, these ligand gated channels gets opened. This is how the impulses are transferred from one terminal to the other terminal, and finally it reaches to the brain. So basically this is how, when there is pain, the information is transferred to the brain. When we perform certain dental procedures under LA, what actually LA does? This local anesthetics, it blocks the sodium gated channel in a small area. That's why we call it as local anesthesia, and hence there will be no stimulus is transferred to the CNS, and it is a reversible blockage of the sodium channels. Once the effect of local anesthesia has gone, the sodium receptor channels, it gets open. Once it is open, the stimulus is transferred to the central nervous system, and this is the reason after performing extraction we prescribe NSAIDs or analgesics to the patient to control the, because patient will be under pain once the LA effect has gone. Cocaine was the first LA to be discovered. Now you have an idea what actually LA does. Let's see how the local anesthesia blocks the sodium gated channels. A is a weak base which is in the unionized form under the pH of 8 to 9. Let's assume this weak base as B. I'll just mention it as B. Let's have a look at the cell membrane, which is made up of phospholipids, that is fatty acids and lipids. These fatty acids and lipids are easily permeable, that can easily permeate the things inside the cell, and hence this B, it is a weak base. It can easily penetrate into the cell. The H plus ions present inside the cell combines with the weak base B to form the ionic form. What happens? This ionic form of La is lethargic, it becomes heavy, it cannot cross over the cell membrane, and hence it stays inside the cell itself, which leads to the formation of functional amide group. What happens here? The ionic form goes and blocks the sodium gated voltage channels. When the sodium gated voltage channels, then there will be no movement of the sodium ions. As a result, there will be slowing of depolarization when there is no movement of sodium ions, and hence the potential also becomes less. As a result of which the stimulus, the impulses are not transferred to the CNS, and hence there is no pain at all. The fastest conduction of impulses occurs in the A delta fibers, which is myelinated now, and the smallest conduction occurs in the C fibers, which is non-myelinated now. In the myelinated now, there are nodes of Ranvier. In these nodes of Ranvier, we have huge number of sodium gated voltage channels. What happens when the La blocks all the sodium gated voltage channels? There will be no impulses to be transferred to the CNS, and hence there will be no pain. The sequence of loss of sensation occurs here. First the pain sensation diminishes, then temperature, then touch, then pressure. This is the specific receptor theory, and it is the most accepted theory. And the next theory is acetylcholine theory. According to this theory, acetylcholine is responsible for nerve conduction. This is not true. Acetylcholine does not involve in the nerve conduction, and hence this is not accepted. Next theory is calcium displacement theory. According to this theory, the calcium ions gets displaced from the calcium receptor site, then it binds to the La, thereby the inhibition of the nerve conduction occurs. This is not true, and hence this is also not accepted. And the next theory is surface charge theory. According to this theory, La binds to the surface of the membrane, then it causes change in the charge of the surface membrane, which causes change in the electric potential, as a result of which there is inhibition of the nerve conduction. But this is not true, and hence this theory is also not accepted. The next theory is membrane expansion theory. According to this theory, La binds to the membranes of the nerve, then it causes expansion, as a result of which there is blockage of the nerve conduction. This is not true, but it is not totally unaccepted also. The La causes expansion of the nerve, but there is no evidence that nerve conduction is entirely blocked by membrane expansion. So this is all about the mechanism and theory, guys. I hope it was useful. Consider subscribing to my channel. Bye. Thank you.